Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we will discuss the problem related to vertical plane surface submerged in liquid. So in the previous lecture, we have discussed the theory part of this vertical plane surface submerged in liquid. The question here I have taken a rectangular plane surface is 2 meter wide and 3 meter deep. It lies in a vertical plane of water and determine the total pressure and position of center of pressure on the plane surface when its upper edge is horizontal and coincides with water surface. And the second point is this is one thing we need to calculate, and the second part is 2.5 meter below the free water surface. So these two things we need to calculate here. So here we can draw a diagram for one condition. First condition is when the upper edge of this rectangular plane. So rectangular plane is given. So let's draw that rectangular plane. So suppose this is the rectangular plane is there, and the upper edge of this plane surface coincides with the water surface. So let consider this is our water surface is there. Okay, this is the water surface is there, and the upper surface of this horizontal plane is coincide with this one. And what are the dimension of this rectangular plane surface? So the width is 2 meter. So I can draw this width. This is 2 meter is given, and the height of this, or you can say the depth deep inside this one, is given 3 meter. Okay, and it lies in the vertical plane in the water. Now this is one condition. Second condition is given another one, same horizontal, like same rectangular plane, and which is situated 2.5 meter below the free surface of water. That means similar kind of diagram we can draw. This is suppose the free surface of water, and the rectangular plane is situated. Let me draw one small one. Rectangular plane is situated, same rectangular plane, dimension same. Okay, because I'm not drawing a little bit below, it will be not visible. So this is the width, same width is there 2 meter, and the depth of this rectangular plane again 3 meter. And the thing is, the distance from here to here is, that is given 2.5 meter actually, that is given 2.5 meter below the free surface of water. So this is the free surface of water. Okay, now here we can say one center of gravity point is there, and that is G point, and one point will be here, that is the pressure point. Okay, the center of pressure, that is, you can say, that is the P point, and the distance from here to this free surface to the center of gravity, that is, we can say this is H bar, and the distance from this center of pressure to this free surface of this, that we can say that is H star. Okay, similarly here also we can get one G point, and here also we'll get P point of this. So similarly here also the H point, H bar point, let's keep it from here to here, the total height covered from the free surface to the center of gravity point, and again this is our P point, that is how much, H star. Okay, so this is the indication of these two diagrams, and now we need to calculate. First one is total pressure. So we know the total pressure formula. Okay, and that is nothing but total pressure F equal to, we know the formula that we have identified in the derivation time, that is rho G, here A H bar, rho G A H bar. This is one formula. And another formula is for us, that is H star equal to, that is second one, position of the center of pressure. This is the position of the center of pressure, how the position is need to be identified. That is H star equal to, we know that Ig by H bar, A H bar plus here H bar is there. So this is the two formula which we know from the derivations. So first one is this one, F equal to rho g A H bar. Second one is S star I equal to Ig by A H bar plus H bar. So first one, let's see what is the condition is there here, G point. Okay, these two equations need to be used for two different cases. So first one is A point, suppose let me calculate F equal to here, rho equal to how much? Now that is water given, so we can consider the 1000 kg per meter cube density of the water, and G value we know that 9.81, and area. So area need to calculate here actually. So area we can calculate here. What is the width and depth is there? 2 meter by 3 meter. So you can write 2 into 3. So that is 6 meter square. This is the area of this. And now H bar required. So H bar here for this condition, you can see this is the H bar. That means the distance from the free surface to the center of gravity point. So the total height is how much? 3 meter. We know that the center of gravity will be situated at the middle of this object. So H bar equal to here this total height divided by 2. So that means 3 divided by 2 equal to 1.5 meter. Okay. So these are the values for this. So here we can calculate the value of F. Easily we can calculate, that is 1000 into 9.81 and into area 6 and into H bar 1.5. So this is near about, if you consider this one 10 into 1.5, there's 15 into 6, 15 into 690, and this is 1000. So near about 90,000 it will come approximately, but it will be less a little bit because it's 9.81 is there. So near about, let's consider 89,000. Okay, so 89,000 Newton will be there, the total pressure on that. Okay, and second one is the point of this H dash, that is Ig by H bar plus H bar. So H bar already we have calculated here 1.5. Now we need to calculate the Ig value. So Ig value we know that that is the moment of inertia about the center of gravity of the area of the surface. So that Ig for this will be BdQ by 12. That is a rectangular plane. So this BdQ by 12 actually already is there to identify the moment of inertia. So in the mechanics you have studied maybe. So that will be a different topic. So you can write this is BdQ by 12. So here I can get it the value B, this one, this width and depth. Okay, so that means 2 into 3 to the power 3 and 12 will get near about 3 9 27 into 2 54 by 12. So near about 4.5 meter. Okay, so this is moment of inertia. Meter to 4 will be there actually, meter cube to the power 4 actually. So this is moment of inertia. So now we can find out H star. So H star equal to, we can write Ig equal to 4.5 and the value of area 6 into H bar. H bar how much here? 1.5. 1.5 plus H bar 1.5. So here 4.5 divided by 9. So 1 by 2. 1 by 2 equal to 0.5. So 0.5 plus 1.5, that is nothing but 2 meter. So H star is 2 meter. Okay, this is the H star. That means the position of the center of pressure from the free surface, that is 2 meter from the free surface. And the force which is acting here that we got here 89,000 near about, and this is h star equal to 2 meter. Okay, this is for first condition. Second condition, if you see similarly the B point, another point with the coincides 2.5 meter below the free surface of the water. So for this also similar value we can consider, but here the h and h star value will be different. H bar first, let identify the h bar. Mostly the h bar will be different here because initially it was from the surface level. Now here the h bar we need to consider half of this, because the rectangular plane how much is there, that is half of this plus the distance traveled from the free surface. So that means h bar equal to, we can write 2.5 plus 3 by 2, that means 1.5. So we can get 4 meter. So previously we got that is 1.5, now it is 4 meter is there. Only that will be the difference, remaining all will be same. So we can write F equal to similar formula rho g ah bar. So that is 1000 into 9.81 again, and into area 6 meter square into ah bar, that is 4. So here we'll get the value in near about 24 into 1000, 24,000 into this 9.81, that means near about 10 if you consider, then 2,40,000 near about will come. So a little bit less than that. So we can write approximately, I'm writing the approximate value, not the exact value actually. So 23 will get like 2,35,000 near about something will get the value, that is the Newton. So this is one of the total pressure of this, and similarly we can calculate the center pressure of that. So that is another one formula, H star. H star equal to, we can write similarly the formula will be Ig by AS bar plus H bar. So Ig value already we got here. So similarly we can write Ig equal to 4.5, and only the difference we got here H bar. Area we can 6 and H bar is 4 plus here 4 is there. So we can write 4.5 divided by 24 plus 4 is there. So this will be a point value actually, 4.5 divided by 24. So if you divide, then we will get near about point some 1 2 something will get. So we will get finally 4 we can write 2. Okay, some approximate value I'm writing 4.2. This is the meter. Okay, now initially see, initially we got the value of this H star is 3 meter, how much, 2 meter. Okay, now we got it the position of this 4.2 meter, because it is situated below the surface level of 2.5 meter. Okay, so like that we can solve the problem, and we can find out the value of this total pressure and the center of pressure of this. Okay, so I hope you understood how to solve the problem, and these are the small competitive exam questions will be asked in the exam, competitive exams, and these two formula if you remember, you can easily solve the problem. If you're having any kind of doubt and queries on this, you can give a comment on the comment box. Thank you all.